This session is on coordinate geometry. In this session, we are going to discuss about the graphs for equations x equals constant and y equals constant. So here you will notice that I have drawn a graph. I have marked the x-axis, the positive part and the negative part, and I have also plotted the y-axis. The origin is also plotted. So now let's consider the equation x equals 3, right? So if I want to plot all points, so x equal to 3 basically means collection of all points, where x always equals 3, right? Now y is not specified over here, but x is specified as 3. So let us mark all those points whose x value is equal to 3. The first point that I notice is 3, 0, that is this particular point. So and at this particular point the value of x is 3 and the y coordinate is 0. Similarly, at this particular point you will notice that the value of x is 3. So the coordinate is 3, y coordinate is 1. This particular point has x coordinate 3 and y coordinate 2. This particular point has x coordinate 3 and y coordinate also 3. This particular point has x coordinate 3 and y coordinate 4. This particular point has x coordinate 3, y coordinate 5, and so on, right? Similarly, there are points below the x-axis also. So consider this particular point. The x coordinate of this point is 3 and the y coordinate is -1. Similarly, here the x coordinate is 3, the y coordinate is -2. So you will notice that all these points have their x coordinate equal to 3 and y coordinate can be different. So what I can say is, if I draw a straight line which is perpendicular to the x-axis, every point that lies on this particular line, right? Every point. So I have not marked many points on this particular line. For example, this point A is what we did not mark. But if you now try to find the coordinate of this point is 3, 6. Similarly, if you take this particular point say B, and the x coordinate is again 3, the y coordinate is 3.5. Similarly, take this particular point is C, the x coordinate is 3 and y coordinate is -1.5, right? And therefore the set of all points whose x coordinate is 3 happens to be this particular straight line that is parallel to the y-axis, or it's perpendicular to the x-axis. And you will notice that this particular line is 3 units towards the right of x-axis, towards the right of y-axis, right? So I can say that the collection of all points when x equals 3 is a line which is parallel to the y-axis, and it is at 3 units to the right of the y-axis, Similarly, let us now try to plot another line which is say x equals -1. So again I am trying to find all those points where the value of x is -1, or basically I am trying to find those points whose x coordinate is -1. I notice that the first point is right over here on the x-axis. The coordinate of this point is -1, 0. I notice that there's one more point which is vertically above it, and the coordinate of this point is -1, +1. So the x coordinate is -1 and the y coordinate is +1. Similarly, this particular point, if you take this point, the x coordinate is -1, the y coordinate is 2. Then there's one more point here, which is x coordinate is -1, y coordinate is 3. There's another line here which is x coordinate is -1, y coordinate is 4. Then you have one more point here whose x coordinate is -1, y coordinate is 5. So now you will notice that the line that contains all these points is again parallel to the y-axis, and it is at a distance of 1 unit towards the left of y-axis. So I can say that x equals -1 is basically a line again parallel to the y-axis, at a distance of 1 unit, towards the left of the y-axis, right? That means if you now notice x equals 3, x equals -1. So when x is equal to constant, I can conclude that when x equals constant, it is basically a line parallel to the y-axis, and the distance of that particular line from the y-axis is going to be equal to the value that is present in the equation. So when x is equal to 3, it was towards the right of y-axis at a distance of 3 units, whereas when x equals -1, it is towards the left of the y-axis at a distance of 1 unit, right? So this is what we can conclude. We can say that when x equals constant, the line is always going to be parallel to the y-axis. So let us now draw a few more graphs. For x equals constant. So you will notice that this particular line is passing through all points whose x coordinate is equal to 1, right? And therefore the equation of this particular line is x equals 1, right? So x equal 1 means the list of all points or the set of all points whose x coordinate is equal to 1, and the line that is drawn right now has set of all its x coordinates equal to 1. So for example, this point is 1, 5. This particular point is 1, 3. This particular point is 1, 2. This particular point is 1, -2. So you will notice that the y coordinate is definitely changing, but the x coordinate remains 1, right? That is why the equation of this particular line is x equals 1. Similarly, I can draw another line which is parallel to the y-axis somewhere over here, right? So let's consider the line M. Let us mark this line M. If you take the coordinates of all these points that lie on this line, so let's find some coordinates. This particular coordinate is the x coordinate is -6 and the y coordinate is 5. For this particular point, the x coordinate is again -6 and the y coordinate is 2. For this particular point, the x coordinate is -6 and the y coordinate is 1. For this particular point, the x coordinate is -6, the y coordinate is 4. For the point lying over here, the x coordinate is -6, the y coordinate is -5. For the point lying here, the x coordinate is -6, the y coordinate is -2. So you will notice that all these points have their x coordinate equal to -6. So I can say that the equation of this line is x equals -6. So x equals -6 can also be written as x plus 6 is equal to 0, right? So the equation of line M, I can write it as either x equals -6 or x plus 6 equals 0. Similarly, if this particular line is marked as line L, then I can say that the equation of line L is either x equals 1 or x minus 1 equals 0, right? So this is the equation of line L. Let us mark one more line on this particular graph. So let us mark the line right over here. So now let us find some points, the coordinates of some points lying on this line. So let us mark this line as line N. So let's find this coordinate. The x coordinate is 5 and the y coordinate is -5. So this is 5 comma -5. Similarly, this point has x coordinate of 5 and y coordinate of -2. This particular point has x coordinate of 5 and y coordinate of 0. This particular point has x coordinate of 5 and y coordinate of 3. This point has x coordinate of 5 and y coordinate of 5. This particular point has x coordinate of 5 and y coordinate as 1.5. So you will notice that all these points have their x coordinate equal to 5, and therefore I can say that the equation of this line happens to be x equals 5. So for line n, I can say that x equals 5 is the equation, or x minus 5 is therefore equal to 0. So this is line n. So let us now mark one more line right over here. Let's mark it somewhere over here. So let us find the coordinates of some points lying on this particular line. Let us mark this line as line P. So this particular point will have x coordinate is negative 1.5. If you notice, it is between -1 and -2, exactly between -1 and -2. So the x coordinate is negative 1.5 and the y coordinate is 3. The x coordinate of this particular point is negative 1.5 again, y coordinate is 1. This particular point has x coordinate of negative 1.5, y coordinate of negative 1. This particular point has x coordinate of negative 1.5, y coordinate of negative 4. This point has x coordinate of negative 1.5, y coordinate of negative 6. This point has x coordinate of negative 1.5, y coordinate of positive 5. So you will notice that all these points have their x coordinate equal to negative 1.5. So I can say that for line P, x is equal to negative 1.5, right? All the points have their x coordinate equal to negative 1.5, and therefore I can say that x plus 1.5 is therefore equal to 0. So this is the equation of the line P. So in short, we can say that when x is equal to constant, the line is always parallel to the y-axis. You will notice that the line is situated at constant units, from the y-axis. If the constant happens to be negative, if the value of the constant, so if constant is negative, then the line is towards the left of the y-axis, and if constant is positive, then the line lies towards the right of the y-axis. So let me pause for a minute and then let's take up some more examples. Let us take some more examples. So let us consider the following equations. Now I want to plot the graph of y equals 4. So I first have to find some points whose y coordinate is 4. One point is right over here. The coordinate of this point happens to be 0, 4. I can also pick this particular point. This particular point has coordinates. X coordinate is 3, Y coordinate is 4. So this is 3, 4. I can pick one more point right over here. So the X coordinate is 2, the Y coordinate is 4. Similarly, there's one more point over here. The X coordinate is 7, Y coordinate is 4. There's one more point here over here. The X coordinate is 5, the Y coordinate is 4. So you will notice that if I draw a line passing through these points, it is going to be a line which is parallel to the x-axis now, right? And pick any point on this particular line and you will find that its y coordinate is always 4. So let us pick these points and let us find their coordinates. The x coordinate of this point is -8, but the y coordinate is still 4. The x coordinate of this point is -5, the y coordinate is still 4. The x coordinate of this point is -2.5, the y coordinate is still 4. So you will notice that y equals 4 is basically a line that is parallel to the x-axis, and it is at a distance of 4 units from the x-axis, right? The distance is 4 units above the x-axis, right? And this line is therefore above the x-axis. Now let us plot the line y equals -1. So again, let us find a few points whose y coordinate is -1. The first point lies right over here. So the coordinate of this point is 0, -1. Then I have one point over here whose coordinate is 3, -1. Then there's one point right over here whose coordinate is 6, -1. Then there's one point over here whose x coordinate is 8, y coordinate is -1. So again, if you think of joining all the points whose y coordinate is -1, you will notice that it is again a line parallel to the x-axis. This line is parallel to the x-axis and it is at a distance of 1 unit from the x-axis. So I can say that y equals -1 is going to be a line which is parallel to the x-axis, and it is at a distance of 1 unit from the x-axis, and also it is below the x-axis, right? It is below the x-axis. And this is how we can plot the line y equals -1. Now let us plot the line, say y plus 2 is equal to 0. So when y plus 2 is equal to 0, I can say that y is equal to -2. So now we need to find all those points whose y coordinate is -2. Pick this particular point. This particular point has coordinates 0, -2. This coordinate has x coordinate -2, y coordinate -2. This point has x coordinate -5, y coordinate -2. This particular point has x coordinate -8, y coordinate -2. Similarly, this particular point has x coordinate 5 and y coordinate -2. So if you think about it, the set of all points whose y coordinate is -2 is again a line parallel to the x-axis. So the line is parallel to the x-axis. Of course, it is below the x-axis, and it is at a distance of 2 units from the x-axis. So it is below because there's a negative sign if you check. So y equals -2. So because there's a negative sign, the line is below the x-axis. And at a distance of 2 units from the x-axis, that is the value of the constant right over here. So let us now plot the line y minus 1.5 equals 0. So I can say that if y equals y minus 1.5 is 0, that means y equals 1.5. So now we need to find all points whose y coordinate is 1.5. 1.5 lies between 1 and 2. So 1.5 is going to be right over here. So this point is 0, 1.5. The point right over here is going to be x coordinate is 3, y coordinate is 1.5. This particular point is going to have x coordinate of 6.5 and y coordinate of 1.5. This particular point over here is going to have x coordinate minus 3, y coordinate 1.5. This point is going to have x coordinate negative 6 and y coordinate 1.5, right? And therefore, we can have a line parallel to the x-axis passing through these points, right? And hence I can say that this is a line parallel to the x-axis, above the x-axis, and also 1.5 units above the x-axis, right? So you will notice that when y is equal to constant, I can summarize this saying that when y equals constant, the line is parallel to the x-axis, if the constant is greater than 0. If constant is greater than 0, it is above the x-axis. If constant is less than 0, it is below the x-axis. And of course, the distance from the x-axis depends on the value of this constant, right? This is what we can summarize from all these graphs. Now remember, when you draw graphs, you should always mark it with arrows because it is a line and line extends to infinity on both sides. And you should also mention the equation of the line on the graph. So this is y equals 4. This is y equals 1.5. This line is y equals minus 1 and this equals y equals minus 2. So let me again pause for a minute and then we will take up some more questions. So let us now take some questions based on x equals constant and y equals constant. Let us consider the following question. Plot the lines for the equations x equals 4. So x equals 4 is basically list of all those points which are having x coordinate of 4. So let me quickly plot a few points where x is going to be equal to 4. If you understand, x is the distance of the line of the point from the y-axis. So all these points that I've marked so far, they have x coordinate of 4. Of course, y coordinate changes, but the value of x coordinate remains constant. And hence I can say that the line that joins all these points, the x coordinate of all these points is 4, and hence the equation of this line is equal to x equals 4. y equals 5. That's the second question. So let's plot all points whose y coordinate is 5. The first point is 0, 5, and then I have 2, 5, 3, 5, 5, 5, 8, 5, and negative 6, 5, negative 4, 5, negative 2, 5. So you will notice that all these points have their y coordinate equal to 5, and hence the line joining them should have the equation y equals 5. So the equation of this line is y equals 5. Then x equals negative 3. So let us plot all points whose x coordinate is negative 3. The first point that comes to my mind is negative 3, 0. Then I have negative 3, 1, negative 3, 3, negative 3, 1.5, negative 3, 2, and there are so many points. So again, the line joining all these points will have the equation x equals negative 3. So this line is parallel to the y-axis. It is at a distance of 3 units from the y-axis, and because it's negative 3, the line is towards the left of the y-axis. So this particular line has equation x equals negative 3, right? And y plus 2 is 0. So if y plus 2 is 0, y equals minus 2. Shifting the 2 to the other side, y equals minus 2. And now let us plot all those points whose y coordinate is minus 2. The first point is 0, minus 2. Then I have 1, minus 2, 2, minus 2, 3, minus 2, and so on. So the list of all points is basically a line that passes through all these points. And hence the equation of this particular line is going to be y equals minus 2, or I can also write this as y plus 2 is equal to 0. So if I were to quickly mark the answers, x equals 4 is parallel to the y-axis. It is towards the right of the y-axis, and that's because x is positive 4, and it is at a distance of 4 units from the y-axis. Similarly, y5 is parallel to the x-axis. It is above the x-axis because y is equal to positive 5, above the x-axis, and it is at a distance of 5 units from the x-axis. Similarly, x equals minus 3. So x equals minus 3 is parallel to the y-axis. Because it's negative, it is towards the left of the y-axis, and it is at a distance of 3 units from the y-axis. Then y is equal to minus 2. This particular line is parallel to the x-axis. It is below the x-axis, and it is at a distance of 2 units from the x-axis, right? So this is how we plotted these lines. Just take a look at the way we plotted it, the logic that we use. Try to understand the logic, and I'm pausing for a minute before I take the next set of questions. Moving to the next set of questions. Let us consider the following question. Plot the graph for the lines x equals 3, x equals -5, y equals 0 and y equals -6. So x equals 3, now I know that x equals 3 is going to be a line which is parallel to the y-axis because all these points contain their x coordinate equal to 3. So let us write the equation of the line on this line. So this is x equals 3. Then x equals -5. So x equals -5 is again going to be a line which is parallel to the y-axis. So this is x equals -5. Then you have y equals 0. So y equals 0 is basically a line which is going to have all its y coordinate 0. So let us think about which points have their y coordinate 0. So if you think about it, these points that lie on the x-axis have their y coordinates equal to 0. And therefore, when I say y equals 0, it basically means the x-axis, right? So x-axis has its y coordinate 0 and therefore y equals 0 basically is the x-axis. So this is y equals 0 and y equals -6. So let us plot y equals -6. Y equals -6 is going to be parallel to the x-axis. It is going to be below the x-axis at a distance of 6 units from the x-axis. So if you notice, this is the line y equals -6. And now we want to find the area of the rectangle that is enclosed by these lines or that is getting formed by these lines. If you notice carefully, the rectangle is getting formed right over here, right? All these lines are forming this particular rectangle. And hence I want to find the area of rectangle ABCD, right? ABCD. A, B, C and D are the vertices of this rectangle. So the area of the rectangle is given by length multiplied by breadth. So the length of this rectangle, this is 5 units, this distance is 5 units and this distance is 3 units. So the total length of the rectangle happens to be 8 units multiplied by the breadth of this rectangle is 6 units. So 8 into 6 is 48. Therefore, the area of the rectangle is 48 square units, right? Now, one important thing that we noticed in this particular question was when they asked the line y equal to 0, when they asked us to plot this line, y equal to 0 was basically the x-axis. And if I want to plot the line x equals 0, then it is going to be the y-axis because on the y-axis all x coordinates are 0, right? So these are two additional conclusions that we could derive based on this particular question. So pausing for a minute, take a look at how things were plotted and then we move on. Moving on to the next question. Plot the lines for the following equations. The first equation given is x equals 0. So we want to find all points whose x coordinate is 0. X coordinate is 0. So if I check which points on this particular graph will have their x coordinate 0, all points that lie on the y-axis. So origin is 0, 0. The point over here is going to have coordinates. X coordinate is 0 and y coordinate is 1, because there's no horizontal movement if you want to go from origin to 0, 1. This particular point would be 0, 2. This particular point would be 0, 3. So you will notice that all the points where x equals 0 happens to be the y-axis, and therefore I can say that the equation of the y-axis is going to be x equals 0. So equation of the y-axis is x equals 0. This is one important conclusion. Equation of the y-axis happens to be x equals 0. And the second part is find y equals 0. So y equals 0 means I want to find all points whose y coordinate is 0. And let us find all those points whose y coordinate is 0. So this is minus 3, 0. This is minus 5, 0. This is 4, 0. This is 7, 0. So the line joining all these points is actually the x-axis. So the x-axis has equation y equals 0. So I can say that equation of the x-axis is basically y equals 0, right? Then we want to plot x minus 1.5 is 0. So x minus 1.5 is equal to 0 implies x equals 1.5, right? So we want to find all those points whose x coordinate is 1.5. You will notice that the line is going to lie between 1 and 2, x equals 1 and x equals 2. And this point is lying to the right of the y-axis. It's parallel to the y-axis. It is towards the right of the y-axis because x is positive 1.5. So this particular line is going to be x equals 1.5. And all the points on this line will have their x coordinate equal to 1.5. Similarly, I want to plot 2y minus 5 equals 0. So let's plot 2y minus 5 is 0, which means 2y is equal to 5, and therefore y is equal to 5 divided by 2, which means y equals 2.5. So we want to find list of all points whose y coordinate is 2.5, and these points have their y coordinate equal to 2.5, right? And therefore the line which is parallel to the x-axis passing through these points will have the equation y equals 2.5. So this particular line is going to have the equation y equals 2.5. It is of course above the x-axis. It is above the x-axis because y is positive 2.5, and it is at a distance of 2.5 from the 2.5 units from the x-axis. So again, pausing for a minute while you take a note of all these graphs, and then we will continue. Moving on to the next set. Plot the lines x equals 4 and x equals minus 3 and find the distance between these lines. So I know that x equals 4 is going to be parallel to the y-axis at a distance of 4 units from the y-axis, and it is going to be towards the right of y-axis because x is positive 4. So this particular line is therefore going to have the equation x equals positive 4. So x equals positive 4. And the second line that we are expected to draw is x equals minus 3. So that line is also going to be parallel to the y-axis, and it's at a distance of 3 units again towards the left of the y-axis. So this particular line has equation x equals minus 3. And the distance between these lines, so these two lines are definitely parallel to each other. They are not perpendicular to each other. They are both parallel to the y-axis, which means that they are parallel to each other. And the distance between them, so because these lines are parallel, you can find the distance between them. The perpendicular distance between them always remains constant. So this particular distance, if you check this particular distance, the distance between this line and the y-axis is 3 units. And the distance between the second line and the y-axis is 4 units. And therefore the total distance between them is going to be 7 units. So I can say that the line x equals 4 is parallel to the y-axis. Is parallel to the y-axis at 4 units towards the right of y-axis. I can also say that the line x equals minus 3 is also parallel to the y-axis at 3 units towards the left of y-axis. Towards the left of y-axis. The lines are parallel to each other. And the distance between them is 7 units, right? Of course, over here you will notice that we should write the scale of the graph. So scale of the graph is going to be on the x-axis and on the y-axis 1 centimeter is 1 unit, right? So 1 centimeter equals 1 unit is the scale for both x as well as y-axis. So this is how we solve this particular question. Pausing for a few seconds before continuing. Plot the graph for lines x minus 2 equals 0. So if x minus 2 is 0, then I can say that x equals 2. And x equals 2 is going to be a line which is parallel to the y-axis. All points on this particular line has the x coordinate equal to 2. So this line is x equals 2. So x equals 2 is going to be parallel to the y-axis and towards the right of y-axis. The second equation is x minus 6 equals 0. So again x minus 6 equals 0 means x equals 6, which is again parallel to the y-axis and again towards the right of y-axis because x is positive 6, right of y-axis. So I can plot the line x equals 6 is right over here. This line is x equals 6. You will notice that every time I am writing the equation of the line on that particular line. So x equals 6 and y equals 3. So y equals 3 means all those points whose y coordinate is 3, and that happens to be parallel to the x-axis. So let's note that down. This line is y equals 3. Again, y equals 3 is going to be parallel to x-axis, and it is going to be above the x-axis because y equals positive 3. And the next line is y plus 3 equals 0. So y plus 3 is equal to 0 means y equals negative 3. Again, this is also going to be parallel to x-axis. But because y is negative 3, it is going to be below the x-axis, right? And therefore, I can plot the line right over here. So y equals negative 3 will lie somewhere over here. Yeah, passing through the negative 3 point on the y-axis. So these are the lines that we wanted, and now we have to find the area of the rectangle enclosed. So if you take the coordinates of the intersection of these lines, these are the 4 vertices. So this is A, B, C, D. And the area of rectangle ABCD is going to be length multiplied by breadth. The breadth of this particular rectangle is 4 units. So one dimension is 4 units, and the other dimension, the perpendicular dimension, is 3 plus 3, that is 6 units, right? And therefore the area of the rectangle is going to be length multiplied by breadth. Length is 4 units multiplied by breadth, that is 6 units, and that's going to be 24 square units, right? This is the area of the rectangle in this particular question. So again, pausing for a minute, take a look at all the lines and how we calculated the area. Moving on to the next question. The next question says, write the equations for the x-axis and y-axis. So for the x-axis, we know that on the x-axis, all points have their y coordinates equal to 0, right? And hence I can say that the equation of x-axis is y equals 0, because if you take any point, the y coordinate of that particular point is going to be 0. This is true for all points on the x-axis, right? So if somebody tells you that the point lies on the x-axis, you can safely assume that the y coordinate of that point is going to be 0. Similarly, I want to find the coordinate of y-axis, the equation of the y-axis. So equation of y-axis is going to be, so every point on the y-axis has its x coordinate 0. So these points are 0, 1, this is 0, 3, this is 0, 5, this is 0, 6, this is 0, -2, and this is 0, -3. So you will notice that all the x coordinates are 0, and that is why the equation of y-axis is x equals 0. And the point of intersection, so point of intersection of x and y axis, point of intersection of x axis and y axis is going to be the origin, right? So the origin will therefore have coordinates 0, 0, right? This is the point where the two axes meet, and we can of course draw it as well. And these are the points where this is the point. There's only one point where these two lines intersect, and that is the origin. The coordinate of the origin is 0, 0. So again, pausing for a few seconds before moving on to the next one. Moving on to the next question. How many points satisfy the equation x equals 3? So we have to find all points which satisfy the equation x equals 3. We know that x equals 3, the line which passes through the point 3, 0, all the points that lie on this line, they satisfy the equation x equals 3. And hence I can say that there are infinite points. There are infinite points. There are infinite points that satisfy the equation x equals 3. And how many points satisfy y plus 2 is 0? So y plus 2 is 0 means y is negative 2. So y equals negative 2 means the line is going to be parallel to the x-axis, and it is 2 units below the x-axis, right? Because y is negative 2. So this particular line is y plus 2 equals 0. So there are again infinite points. There are infinite points that satisfy the equation y plus 2 equals 0, and there are infinite points because a line is composed of infinite points, right? So on this blue line that has been marked, y plus 2 is 0, there are infinite points that lie on this particular line, and therefore there are infinite points that satisfy this equation. Now the next question is, how many points satisfy both the equations? So if you think about it, if I take some random points, let's take this point as A, this point as B. Let us take this point as C, this point as D, and let's pick another point over here as E. So the point A satisfies y plus 2 is 0 because it lies on the line, but it does not satisfy x equals 3. Similarly, point B, it lies on the line y plus 2 is 0. That means it satisfies the equation. But it does not satisfy the equation x equals 3 because it does not lie on the line x equals 3. The point C, it satisfies x equals 3 because it lies on that particular line. But it does not satisfy y plus 2 equals 0 because the point C lies on the line x equals 3. And it does not lie on the line y plus 2 is 0. The point D is unique in the sense that D is actually lying on both the lines. So D satisfies y plus 2 is 0 because it lies on that line. And it also satisfies x equals 3 because it lies on that line as well. So this is a point which satisfies both the equations. The point E does not satisfy y plus 2 is 0 because it does not lie on that line. It also does not satisfy x equals 3 because it does not lie on that line as well. So the point D, which is the intersection of these two lines, is the only point that satisfies both the equations. So the answer to this question, the question is how many points satisfy both the equations? There is only one point, which is the point of intersection, that satisfies both the equations. So I would say the point of intersection of these two lines is the only point that satisfies both the equations, right? And therefore this is an important concept that we have arrived at, that when you have two equations, the point of intersection is the only point that actually satisfies both the equations, right? This is a very important conclusion that we have reached in this particular question. So we are going to end our today's session over here. I hope you understood all the questions that were discussed today and all the concepts that were introduced to you today. Pausing for a minute before I end today's session.